So guys, here we back again. I am Mathew, Javier, a student of Batangas State University taking Bachelor of Science Information Technology. Now, we are in the Chapter 5 tutorial in the CCNA 1. So, Chapter 5 tutorial, so let's go. First is the Ethernet. So, what guys is an Ethernet? Uh, Ethernet is now the predominant LAN technology in the whole world. So, Ethernet also that operates the data link layer and the physical layer. The Ethernet protocol standards define many aspects of the network. Communication, including frame format, frame size, timing, and encoding. When the messages are sent between host and the Ethernet network, the host format the messages into frame layout that is specified by the standards. Because guys, the Ethernet is comprised of standards as these lower layers. It may be understood in the interference to the OSI model. The OSI model separates the free or the data link layer rather functionalities of addressing, framing, and accessing the media from the physical layer standards of media. Ethernet standards define the both layer 2 protocols and the layer 1 technologies, although Ethernet specification supports different media bandwidths and the other layer 1 and 2 variations, the basic frame format and address scheme is the same for all varieties of Ethernet. So these chapters will examine the characteristics and operation of Ethernet as it has evolved from a shared media contention-based data communication technologies to today high bandwidth with full duplex technologies. So now we're going to let's go. The next topic that we are relieved is the Ethernet protocol. So an Ethernet protocol which have the Ethernet encapsulation, max sublayer, Ethernet evolution, Ethernet frame fields, and what we call the ACK and LSC sublayers. So first, the Ethernet encapsulation. So guys, Ethernet encapsulations that have Ethernet is most widely used LAN technology today. Ethernet operates in the data link layer and the physical layer. It is a family of networking technologies that they are defined in the IEEE, and the Ethernet supports data bandwidths of 10 MBs, 100 MBs, 1000 MBs to 1 gig, 10,000 Mbps or 10 gig GPS or the 40,000 Gbps and 100,000 or 100 gig per second. So as shown in the figure 1 as shown in the NetAcad, so Ethernet standards define both the layer 2 protocols within the layer 1. So technology guys is for the layer 2 protocols must have all 102 IE standards. Ethernet relies on the two separate sublayers of the data link layer to operate the logical link control or LLC in the MAC sublayers. So an LLC sublayer is that the Ethernet LLC sublayer handles the communication between the upper layers and the lower layers. This is typically between the networking software and device hardware. The LLC sublayer takes the network protocol data, which is typically an IPv4, and adds control information to help the delivery the packet to the destination mode. The LLC is used to communicate with the upper layers of application and transition the packet to the lower layers for delivery. So, MAC sublayer. So, MAC constitutes the lower sublayer of the data link. MAC is the implemented by hard work by typically in the computer. And I see the specific are the listed in the IEEE standards. Figure 2 lists common IEEE Ethernet standards. So that is the data encapsulation. So, and the next one is the Ethernet Ethernet MAC addresses. So MAC addresses and hexadecimal. MAC addresses and hexadecimal, guys, is Ethernet MAC addresses is a 48-bit binary value expressed as 12 hexadecimal digits, 4 bits per hexadecimal. So just as decimal as base as number system, hexadecimal is base 16 system. The base 16 number system uses the numbers 0 to 9, and the letters A to F. Figure 1 shows the equivalent decimal and hexa values for the binary to zeros to ones. It is here expressed to value a single hexadecimal digit then as your binary. So guys, note, it is important to distinguish hexadecimal values from decimal values regarding to the characters 0 to 9 as shown in the figure. So, the next one is MAC address or Ethernet identity, frame processing, MAC address representation, and unicast address, broadcast MAC address, and multicast MAC address. So, when we say unicast MAC address in Ethernet, different for MAC addresses are used for the layer 2 unicast, broadcast, and multicast communication. So, a unicast MAC address is the unique address used when a frame sent to a single transmitting device to a single destination device. There are also example in chapter 5, 5.1.25. So there are example a host with IPv4 address of 592.168.5. It is a source. Request from a web page from the server at IPv4 unicast address of 192.168.200. For a unicast packet to be sent and receive a destination IP address, it must be in the IP packet header. A corresponding destination MAC address must also be present in the Ethernet frame header. The IP address and MAC address combine to deliver data to one specific destination host. So that is a unicast. The next one is the broadcast MAC address. So a broadcast MAC address, guys, is it contains a destination IPv4 address that has all ones. In the host portion, the numbering in the address means that all hosts on the local network broadcast domain will receive and process the packet. Many networks protocols such as DHCP and ARP uses broadcast. So that is all for broadcast MAC address. So we're going to the multicast. Multicast address would be used in remote gaming where many players are connected remotely but playing the same game. Another use of multicast address is the distance learning, though video conferencing where as many students are connected to the same class. So multicast addresses allow a source device to send a packet to group of devices that has been belong to the multicast group are assigned to multicast group IP address. the range of IPv4 multicast addresses, the range of IPv6 multicast addresses begin with FF two zeros because multicast addresses represents group of address, sometimes called a host group. They can also be used as the destination of a packet. The source will always be a unicast address. So guys, next is what we call LAN switches. So LAN switches have the MAC address table, the switch forwarding methods, and switch port settings. So first is we have the switch fundamentals. Uh, there are always a note that the MAC address table is sometimes referred to as a content addressable memory or CAM table, while the term CAM table is fairly common for the purpose of this course. We will refer to it as MAC address table. So as layer 2 Ethernet switches uses MAC address to make forwarding decision, it completely unaware of protocol being carried in the data portion of the same, such as an IPv4 packet. The switch makes its forwarding decision based on the layer 2 Ethernet MAC address. So that is a switch fundamentals. So it have also learning MAC addresses, filtering frames. They have also we have also called activity, which is switch it. So if you want to watch my video on the YouTube, I have a video of an activity of switch it in my YouTube channel. So watch it, guys. So the next one is the MAC address table and switch forwarding methods, switch port settings. So first, on the switch forwarding methods, it have frame forwarding methods on Cisco switches. So frame forwarding methods on Cisco switches. So it has switches use one of the following forwarding methods for switching data between network ports. First is store and forward switching, cut-through switching. So store and forward. A store and forward switches receives the entire frame and computer the CRC. If the CRC is valid, the switch looks up the destination address, which determines the outgoing interface. The frame is then forwarding out of the correct port. So there is also the cut-through process. A cut-through switch forwards frame that is entirely received at a minimum. The destination address of the frame must be read before the frame can be forwarded. So that is the store and forward and a cut-through choo-choo. So there are cut-through switching, memory buffering on switches. So the next one we're going to tackle is address resolution protocol. So address resolution protocol, under it is MAC and IP, ARP and ARP issues. So we're going to tackle the MAC and IP. Under MAC and IP, destination on the same network, destination on a remote network. So in the destination on the same network, physical address, the MAC address, used for Ethernet NIC to Ethernet NIC communication on the same network. Logical address, the AP address used to send the packet from the original source from the final destination. So guys, in this thing, IP address are used to identify the address of the signal source of the final destination. The destination of IP address may be on the same IP network as the source or maybe a remote network. So destination of the same address. So the ARP. What is an ARP, guys? ARP is recall that device will have an IP address on the Ethernet network. It also have Ethernet MAC address. When a device sends to Ethernet frame, it contains two addresses. First is the destination MAC addresses. Second is source MAC addresses. So a destination MAC address is MAC address of the Ethernet NIC, which have be either the MAC address of the final destination device of the router. Second is that the source MAC address, the MAC address of the sender's Ethernet NIC. So the issues of ARP. Issues of ARP as a broadcast frame, an ARP of requests received and processed by every device is a local network on a typical business network. So this broadcast would probably a minimal impact on the performance. However, if a large number of devices were to be power up and start accessing network at the same time, there could be some reduction in the performance in short period of time as shown after the devices send out the initial ARP broadcast and have learned necessary MAC addresses, our impact on the same network will be minimized. So guys, that is all about my video. That's all, and thank you.